Hi children, welcome to my YouTube channel. Today we are going to discuss further questions in topic moments. If you come up to the first question, a plank AE of length 6 meters, when you are talking about this plank, first fact we have to consider is whether it's a uniform plank or a non-uniform plank. If it is a uniform plank, what we need to understand is the center of gravity works at the midpoint. Other than that, it should be a point deviated from the midpoint. Let's go ahead. And weight 100 newtons. Rest in a horizontal position on two supports B and D. Since if it is in rest, means its object is in equilibrium. Therefore, we can consider upwards force is equal to downwards for this kind of a question. And moments, if you consider the moments around 1 point, the clockwise moments equals to anti-clockwise moment, where this length AB is 1 meters and DE is 1.5 meters. A child of weight 145 stands at C. So therefore you can mark downwards 145 over here as shown in the diagram. The child is modeled as a particle and the plank as a uniform rod. Since the rod is uniform, you can mark the center of gravity at the exactly midpoint, that is 3 meters from point A or 3 meters from point E. Whatever the way, you get the same answer. Right. They ask you to calculate the magnitude of the force exerted by supports and plank B. So, since if this is working on two planks, you can mark the reaction over here, RB or R1, you can mark any way you like. And reaction over here, D is RD or R2, anyway you can mark it. Here there is no relationship between RB and RD is not given, so you can mark it as independent facts over here, right? Okay. Let's go ahead with the mark diagram and let's see how to find the answer for that question, right? We can mark this is RB and RD since there is no relationship given over here. In previous video, we already observed in certain question they have given some relationship between these two reactions. In that case, you have to mark. Other than that, you are totally independent to mark with two different variants, right? Okay. Let's see how to do this question. The first question is to find the reaction at plank at B. We need to find RB. To find the value for RB, I will consider the moment at D. What is the use of finding the moment at D? If you start to find the question from the point at moment D, the moment due to RD is get cancelled because here the moment from RD become RD into 0. So the expression what you obtain here would be independent from RD. Therefore, it would be a single variable equation and you can find the RB very easily, right? Let's start from to find the moment around D. First, we will mark the clockwise moments. What are the clockwise moment facts? This is due to clockwise moment fact. How do you identify with this clockwise or anti-clockwise? Hold it from here and see whether if you apply a force this way, if I hold it from here and if you apply a force over here, which way it rotates? It rotates like this, that is clockwise. Therefore, RB into what is the distance from here to here? We know that this total length is 6. Out of 6, if you remove these two lengths from here and here, you can get the length from RD to B. Or you know that the total length is 6. 6 minus 1.5 minus 1. So you can get the length from RB to DE, length from B to D would be 3.5. Simple. Out of 6, you can subtract these two figures, right? Equals to now the anti-clockwise moments. What are the facts effect for anti-clockwise moment? These are the facts effect for anti-clockwise moment. So you can say 100. And from this question, what we can understand is in the previous question they mentioned the boy of mass 145 stands at C. C is the midpoint of AE, and here we know that the rod is a uniform rod. Therefore, that weight of the rod also works at the same point. Therefore, the moments due to point C would be addition of these two. That is why I just got it as 100 plus 145 into what is the length from here to here. We know that it's a midpoint. The length from here to here would be 3 meters, and here to the length should be 1.5 meters. Therefore, This length would be obviously 1.5 meters. So you can get this answer 3.5 RB equals to 245 into 1.5. By simplifying, you can obtain the answer RB as 105 newtons. Right. Then our next question is to find the magnitude of the force exerted by support on plank D. We need to find the reaction at RD. To find the reaction at RD, I will use another technique. I know that since this object remain in equilibrium, upwards forces equals to downwards forces. I am using that. So you can say upward of the upwards forces RD plus RB is equals to downwards forces would be 100 plus 145. Then 200, so you can say RB value is 105 plus RD equals to 245. Out of 245, the value of RB 105, if you remove it, you can get the answer as 140. So the reaction at RD would be 140. If you prefer, you can use another technique as well. That is, I need to find the reaction at RD. No? Then I will consider the moment at B. That one also another technique can find it, but if you use that way, the question would be little bit longer because you are finding another moment. So rather than that, doing it using this technique is easy. If somebody is interested on that, I will show you how to do this. There is no moment due to RB. Then I'll consider the clockwise moment equals to anti-clockwise moment. Here to here, the length is 3 meters. Here to here, the length is 1 meters. Therefore, the length over here is, here to here would be 2 meters. Then you can multiply 2 into addition of this to 245. 2 into 245. That is equal to the anti-clockwise moment. Length from here to here. We know that the total length is 6 out of 6. If you subtract this to 2.5, then from here it will be 3.5. 3.5 into RD. So you can write 3.5 into RD is equals to 2 into 245. If you use that technique even, you can get the same answer over here. That is the way of solving the first question, right? Okay, right. Then we will come up to the part C, right? The child now stands at a different point F on a plank. The plank is in equilibrium and on the point of tilting at D. So if he's standing at a 1 point dimension, it's tilting about D. We already learned from the previous topics. If you tilting from D, what is the theory we know? The reaction at D would be 0. Let's go ahead with the diagram and let's try to understand this theory. Right, okay. As I mentioned, I will consider the person is standing at a distance of x. Doesn't matter, if you want, you can mark a distance over here as x, but you know that from your common sense, if the object is to tilt from here, the person has to stand from here. Doesn't matter if you are just confusing with this fact, you can mark a distance x at or somewhere over here, right? Then I'll consider to get the answer for this, I'll consider the moment around D. The fact I am considering the moment around D is, if you consider the moment around D, you can understand that the moment due to RD get cancelled because RD into 0. Therefore, you are obtaining answer of a single variable with x, right? Then if you work out over here, the clockwise moment, x into 145. That is equals to, this distance is 1.5. How does this 1.5 came? Because from here to here, this is the midpoint of the rod, that is 3 meters. And here to here, the length is 1.5 meters already given. Therefore, this length would be 1.5. Then you can write 1.5 into 100. With that, if you simplify, you will obtain the answer as 103. That means if this boy travel away 1.03 meters over here, you will obtain, so what happened here is that if you travel for 1.03 meters, object tends to tilt from here. If you move little bit further, definitely the rod will topple like this. It will rotate over here and it will fall from this end. That's the theory we need to understand from the first question. Right. Let's move up to the second question. A uniform rod AB has a length of 4 meters and 150 newtons. What are the facts you can understand? Since it's uniform, the center of gravity works at the midpoint 2 meters from this corner. Right. So you can mark from 2 meters 150. Right. The rod rests in equilibrium in the horizontal position. If it is in equilibrium, upwards forces equals to downwards forces. With the meantime, clockwise moments equals to anti-clockwise moment. Then there it's kept on two positions, two supports. AC is 1 meters and AD is 2.5 meters. A particle of weight W Newton is attached to the rod at point E. They haven't given any fact about point E, then I will consider the distance from here to here, whatever the point, as X. Length is X and the weight of W works downwards. The rod remain in equilibrium. Magnitude of the reaction at C is now equals to the magnitude of the reaction at D. Therefore, when you mark the reactions, you can mark it as R and R. Right. Show that W is equals to 150 divided by 7 minus 4x. Right. Let's come up to the first question. If you mark, as I mentioned in the previous section, the two reactions are same and the weight is downwards, and we will assume that the weight W acts at a distance of x. Right. What is the fact over here? They mentioned AE is x. At a AE of x meters, there would be an object weight of W newtons. Right. That's how it came. Right. Then if you want to find the value of that, what can I get here is I will consider the moment about A. Right. If you consider the moment about A, you can understand that clockwise moments equals to anti-clockwise moment. What are the clockwise moment facts? This W and this 150 newtons. The distance from here to here would be x into W, Wx. And here to here the distance. We know that is the midpoint of a uniform rod of 4 meters. So the here to here the length should be 2 meters. 2 into 150. Yeah, those are the two facts effect for clockwise moments. Anti-clockwise moments due to these two. So you can say here to here the length. We know that that is 1 meters. 1 into R. The value is 1 into R, and from here to here the length is 2.5. It's given in the previous question here. 2.5, and this is 1, right? Okay, that is 2.5 into R again. Then if you simplify this, you will obtain the answer Wx plus 300 equals to 1R plus 2.5R is 3.5R. I'll keep this equation as the first equation, right? Then if the object remain in equilibrium, we know that upwards forces equals to downwards forces, right? What are the upwards forces? R plus R equals to downwards forces, W plus 150. Then you can say R is equals to W plus 150 divided by 2, right? Then I can replace this R over here. Then what you get here is Wx plus 300 equals to 3.5. I wrote here as a fraction 7 over 2 into W into 150, because this R is W plus 150 over 2, sorry. Right, with that, if you can say this is 2 into 2 is 4. I can draw this 4 to other side. 4 times of Wx plus 300 equals to 7W plus 7 into 150 is 1050. If you simplify this, 4 into Wx is 4Wx plus 4 into 3000 is 1200 equals to 7W plus 7 into 150 is 1050, as I mentioned in the previous. Then I can plot this 150 to this side and 4Wx to this side. So it will turn up to 1200 minus 1050 equals to 7W minus 4Wx. Out of this expression, if you take W out, 7 minus 4x, then W would be 150 divided by 7 minus 4x. That is the way of obtaining the expression as the answer in part A, right? Then if you come up with a part B, hence deduce the range of the possible value of x, right? Then obviously we know that x should be more than 0. Length cannot be negative. So this is a one variable where we can understand a one condition which is satisfied. And other than that, we know that this 150 over 7 minus 4x is the real, it's a value for W. We know that weight cannot be negative. Therefore, this value should be definitely greater than 0. Then we know that 150 is obviously a positive answer. Therefore, you can say 7 minus 4x also should be greater than 0. To be any division or a fraction to be positive, if the numerator is positive, definitely the denominator must be positive itself, right? Then if you simplify, you will obtain the answer x is less than 7 over 4. This is a simplification of this inequality. Then we know that x is greater than 0 and x is less than 1.75. That is the way of obtaining the answer for the question number 2. Right. Then let's move up to question number 3. A uniform plank AB has mass of 40 kilograms and length 4 meters. Therefore, you can mark the weight 40g downwards from 2 meters from this corner or this corner, right? Since the total length of the rod is 4 meters and center of gravity is at the midpoint, right? Supported at two horizontal positions at two smooth pivots, right? So here one reaction and reaction still we don't know whether we have to mark these two reactions with a relationship or you can just mark it as RA and RC, right? They mention the length from A to C is 3 meters. A man of mass 80 kilograms stands on the plank with remaining equilibrium. The magnitude of the reaction at A is twice the magnitude of the reaction at C. A is twice as C. So therefore you can mark here the reaction as R and here the value as 2R, right? The magnitude of the reaction C is Rn. So I can mark it as Rn and this value should be 2 times of Rn. The plank is modeled as a rod and the man is modeled as a particle. Find the value for R, right? Let's go ahead with the answer. As I mentioned, here the reaction is R and here the reaction is 2R, right? I will assume the man is standing at a distance of x meters. Therefore, his weight 80 grams, 80 g, not 80 grams, 80 into gravitational constant is the weight over here, and here the length is 2 meters since this rod is a uniform rod, right? So these other length 1 meter is already mentioned over here. To find the value for the first part of the question is to find the value of R. How do you find the value of R? I'll consider the vertical equilibrium. Upwards forces equals to downwards forces. 2R plus R is equals to 80G plus 40G. That is 120 G is a 9.8. With that, if you simplify, you can obtain the answer R as 392. Here the value is 392 and here the value is 2 times of 392, right? Those are the two figures, right? Then the part 2. The part 2 question is find the distance of the man from A. We need to find x value over here. To find the x value over here, I'll consider the moment around A. Therefore, nothing to worry. There won't be any moment due to 2R won't be come up to the count. So you can mark 80G into X, the clockwise moment, plus 2M into 40G. Over here, clockwise moments, X into 80G plus 2M into 40G equals to this value. Here the length is 3 into R. This is the anti-clockwise moment, right? Then we can say over here, if you take, if you simplify this one also 80G, then if you take 80G out from here, X remain and from here, 1 remain equals to 3 into R. R value you already found from the previous question, right? Then you can say x plus 1 is equals to 1176. That is 3 into 392 divided by 80 into 9.8. G is 9.8. From here you can get the answer x as 0.5. That means the man stands at 0.5 from A. That is the answer for question 3, right? Then part C, they ask about what is the condition where you have considered when you're modeling the plank as a uniform rod. If it is uniform, what you can say? You can say the center of gravity works at the midpoint. The plank as a rod. If the plank is a rod, there is, you know that if you keep some kind of a plate thingy, the center of gravity works at a 3D, at a 2D fact. So you have to consider the length as well as the breadth when you consider in the center of gravity. If it is a rod, we can consider the center of gravity in 1D fact. So you can say no need of considering the thickness where when you are working out with the question of a rod. The man as a particle. You know that if a person standing at a point, he is keeping two legs. So the reactions working at two different points and your weight is working along both foots. But if you consider the particle, we can mark the weight at a one point, not from 2 point. That is the way we use the assumption to work out our question into with some kind of assumption to obtain the answer over here. Question number 4. A non-uniform rod. Okay, that's another interesting point. The rod is non-uniform rod, right? Since the rod is non-uniform, we cannot say the center of gravity is at the midpoint, right? AB has a length of 4 meters and weight of 150 newtons. So in this case, sometimes they might given you where the center of gravity is working at, or sometimes we need to find it as the answer for this question, right? They kept on two supports, AC where its length from A to C is 1 meters and DB where the length from B to D is 0.5 meters, right? As shown in the diagram. The center of the mass AB is x meters from A. From here, x meters. That means we need to find the value as an answer, right? The particle of W Newton is placed on point A. So therefore you can mark W, not WG. This is W since it's weight. The rod remain in equilibrium and the magnitude of the reaction C on the rod is 100 Newton. So here the reaction is 100 Newton. So you can mark the reaction over here as R if you want, right? Show that 550 equals to 7W equals to 300x. Let's see how to obtain these answers, right? We know that reaction over here is 100. I will mark the reaction over here as R. Later on I can find this value. The downwards forces are the weight of the rod and the weight you added over here, right? Then if you put upwards forces, what are the upwards forces? 100 plus R. This is come as a optional value. 100 plus R is equals to W plus 150. Then I can keep this 100 to this side and turn up to R equals to W plus 50. That is how this R50 plus W came to the count, right? Then I'll consider the moments around A, right? If you consider the moments around A, the moment due to W won't be coming to the count because W into 0. Then you can say clockwise moments equals to anti-clockwise moment. If you consider the anti-clockwise component, 1 into 100 plus 1 plus 2.5 is 3.5 into 50 plus W. We already found this value for R equals to clockwise component x into 150. Then 100 into 1 is 100. W into 3.5 is 3.5 W. 3.5 into 150 is 175. 150 into x is 150x. With that, this is 275 equals to 3.5 W equals to 150x. To remove this decimal answer, I'll multiply entire expression by 2. 275 into 2 is 550. 3.5 W into 2 is 7W. 150x into 2 is 300x. That is the way of obtaining the answer what you need to show in part A, right? The particle is now removed from A. Now it's not there. So when you make a small change, even the entire facts in this question, it changes, right? Okay. The particle is now removed from A, therefore the reaction over here and here would be now totally different. From A and placed on rod B, it's kept over here, so we can mark W over here. The rod remain in equilibrium and the reaction at C is on the rod now has a magnitude of 52. So now here you can mark the reaction as 52 and here this value is R, sorry. It's not the previous value over there, right? Obtain another equation connecting W and X, calculate the value of X and value of W. Let's see how to do this question, right? Now in the second diagram, here the reaction is 52 and here the reaction is R. Later on we can find this value to do this calculation, right? The downwards forces are 150. Now here the W come up to a value over here because now you place this object at point B. So if you put upwards forces equals to downwards forces. What are the upwards forces? 52 plus R. 52 plus R equals to downwards forces. 150 plus W. 150 plus W. So if you brought this 52 to other side, 150 minus 52 is 98 plus W equals to R. Then I'll consider the moment from B. If you consider the moment from B, clockwise moments equals to anti-clockwise moments. If you consider the clockwise moments, we know that from here to here, the length is 3. Length is 3 because we know the total length is 4. Here the length is 1. Therefore, here the length is 3. 3 into 52 equals plus the other clockwise moment is this bit. 98 plus W, I already got it from here. 98 plus W into 0.5 equals to anti-clockwise moments. From here to here the distance is 3. Here the length is how much, children? So over here, the 2.5 to the midpoint. Therefore, how do you find the length from here to here? We know that the total length is 4 and here the length is x. Then this length should be how much? This length should be definitely 4 minus x. Don't misunderstand about these two figures. This is 2.5 is to the what you call center of gravity, the midpoint. But sorry, the 2.5 is the length from here to here, not the center. So that means it doesn't mean that the length from here to is 2.5. The total length is 4 and here the length is x. Therefore, this length should be 4 minus x. 4 minus x into W. 52 into 3 is 156. 98 into 0.5 is 49. 0.5 into W is 0.5 W. 150 into 4 is 600. 150 into minus x is minus 150x, right? If you add these two, turn up to 400 and it will turn up to 9 plus 5. 9 plus 6 is 5. It's 205. 205 plus 0.5 W is equals to 600 minus 150x. Then to remove this decimal point, I'll multiply everything with 2. Then 205 into 2 is 410. This is W. This is 1200 and this is 300x. Then you can say W is equals to, if I brought this 400 to other side, 1200 minus 410 is 790 minus 300x, right? Then how do you find the value for W and X? We know that from previous equation we already got 550 plus 7W equals to 300x. From this equation we know that W is equals to 790 minus 300x. Then I can say W equals to 700 minus, instead of 300x, what can I replace? I can replace with 550 plus 7W, right? Then we can say 750, I brought this 7W to other side, it's 8W equals to 709 minus 150, 550, it's 240, W equals to 30. Then if you know the value for W, from this equation, I can obtain the answer for X, right? So I can replace here the value is 30, 410 plus 30 equals to 1200 minus 300x. With that, you will obtain the answer for X as 2.53. That's a way of obtain the answer for this question, right? Let's move up to question number 5. Right. A lever consists of a uniform steel rod AB. If this rod is uniform, what we can understand is center of gravity is at the midpoint 1 meters, right? Which rested, to 200 meters, 100 newtons, 100 newtons. So therefore you can mark 100 newtons over here from 1 meters, right? Rest in a smooth pivot at point C, the load of 1700 newtons suspended from point B. From here the downwards, 1700 newtons, right? Right. The lever held in equilibrium, the horizontal position by the force applied at point A. I just applied a force F over here, right? The rope is modeling as a light string given that BC is 0.25, right? Find the magnitude of the force applied at A, right? Okay, let's go ahead with this, right? Then we can work out here the force is 1 newtons. The distance from the total length is 2 meters. From this corner to the midpoint is 1 meters. This value is 0.25. The value applied over here is that F. I just consider as F, right? Then I'll consider the moment around C. What is the advantage of considering the moments around C? If you consider the moments around C, the moment due to Rn can be ignored or it get cancelled out, right? Then I can consider the clockwise moments equals to anti-clockwise moments. Anti-clockwise moments are the moments due to Fa and 100 newtons. Clockwise moments are the force due to 1700 newtons, right? We know that here to here the length. How do you get the here to here the length? We know that the total length is 2 meters and length from here to here 0.25. Therefore, this length would be 1.75. 2 minus 0.25 into Fa. This length. Then we know that here to here the length is 1 meters and here to here the length is 0.25. So this should be 1 minus 0.25, that is 0.75 into 100 equals to 1700 into 0.25. If you simplify, 2 minus 0.25 is 1.75 Fa. 100 into 1 minus 0.25 0.75 into 100 is 75. 1700 into 0.25 is 425. If you plot is 75 and if you divide by 1.75, you will obtain the answer Fa as 200 newtons. Right. When you come up with part B, the position of the pivot is changed so that now the position of pivot is changed here. So that the load remain in equilibrium when the force at A has a magnitude of 150. Find the nearest centimeter, the new distance of the pivot from B. We need to find the distance from here, right? Okay, let's go into the question. I'll consider now the position of C. Initially, it was at 0.25. Now I'm changing this position, right? The length from B I'll consider as X, right? Then to work out, the easiest way is I'll consider the moment around C. Then clockwise moments equals to anti-clockwise moments. And we know this force is 150 for the new system, right? Right. So we can work out here to here the length is how much? The total length is 2. This length is X, means this should be 2 minus X. 2 minus X into 150. Right. And here to here the length is 1 because it's a midpoint of 2. Here the length is X, that should be 1 minus X. This length is 1 minus X into 100 equals to this length is X into 1700, right? Then from this point you can understand 150 to 2 is 300, 150 to minus X is minus 150X. This is 100 minus 100x, 1700x. With that, if you simplify, you will obtain the answer as x is equal to 0.205. From this way, you can understand the new position would be at a length of 0.25 meters from B, right? That is the answer for that question, right? The next question. The plank AB has a length of 4 meters. From here to here is 4 meters. It lies on horizontal platform with the end A lying on the platform and B projecting over the edge as shown in the diagram. The edge of the platform is at point C. It's like it's balancing over here, right? Jack and Jill are experimenting with the plank. Jack has a mass of 48, therefore weight is 48g. Jill has a mass of 36, that means weight is 36g. Has discovered if Jack stands at B, that means from here it's 48g. And Jill stands at A, from here 36g. BC is 1.8 meters. BC is 1.8, so the total length is 4. The plank is in equilibrium on the point of tilting about C. That means it's balancing over here, right? Okay. By modeling the plank as a uniform rod, if it is uniform rod, center of gravity works at the midpoint of AB, that is 2 meters. And Jack and Jill as a particle, therefore you can mark the forces exactly from one point. That is the assumption where we make with the objects are particle. Find the mass of the plank. We don't know, but the mass of the plank over here, right? Right. Then we can mark this is the pivot point. We know that if it is a uniform rod, the total length from here to here is 2 meters, and this one also 2 meters. The weight is mg. I'll consider the mass as m. Then here it's 36g. The mass of Jill. Jill is standing over here and Jack is 48 in the other side. That is 48g. Then I'll consider the moment around C. If you consider the moment around C, yeah, then what is the distance from here to here? It's 1.8 into 4.8g, that is a clockwise moment, equals to anti-clockwise moment. Anti-clockwise moments are due to these two forces. 0.2 into mg plus 2.2. 2.2 into 36g, right? If you simplify, 48g into 1.8 is 86.4g. Yeah, 0.2 into mg, 0.2 mg. 36g to 2.2 is 79.2g. With that, I can bring all the terms containing g. The other fact, we can cancel all these terms at once. Therefore, turn up to 86.4 equals to 0.2 m plus 72.2. So I can plot this 79.2 to other side. 0.2 m equals to 86.4 minus 79.2. With that, you will obtain the answer. 0.2 m equals to 7.2. Therefore, m is equals to 36. That means the weight of the rod is 36 kilograms, right? Okay. Right. They now alter the position of the plank. Now you just change the position of this rod. Therefore, the what do you call that position of the plank? It changes, right? Relation to the platform that the Jill stands at B. Now here it's Jill. 36 is here, and Jack stands at A. Now here it's 48. The plank again in equilibrium on the point of tilting about C. That means it's balancing over here. Find the distance of BC and the position. Find the distance from here to here. That's what we need to find this question, right? Okay. In part B, we can work out. Now the tilting point is at a distance of x. Other facts are the same way. Now we know that the mass of the rod is 36, so you can use that one because mass of the rod does not changes with the position where they keep up this rod, right? Then I'll consider the moment around C. Right. Clockwise moment C equals to anti-clockwise moment. Prior to that, I'll consider the distance from B to C is x. Right. Then we know that first I will get the clockwise moment. We know that the total length from here to here we consider as x to the center, or the center of gravity to that point is we consider as 2. Therefore, you can consider this distance as right. So over here, this distance you can consider as x minus 2, and here to here the distance is x minus 2, and here with the total distance as x. So I'll consider x into 36g. That is the moment due to this force, and this force here the length is x minus 2 into 36g. Hopefully you can understand how this x minus 2 came. Here to here the length is x, and here to here the length is 2 to the midpoint. Therefore, this length should be x minus 2, right? Equals to this length. We know that the total length is 4 meters, and this length is x, mean this length should be 4 minus x. 4 minus x into 48g, right? With that, what you can get here is that all the terms you can divide by 12g. If you divide 36g by 12g, it is 3x. This is 3. If you divide by 12g, it's 3. X minus 2 into 48g divided by 12g is 4 into 4 minus x. Then you can expand the brackets and you can obtain the answer for x as 2.2 meters. Right. That is a way of understanding the question number 6, and this is a way of getting the answer for question number 6. Right. If you come up to the next question, question number 7. A plank of wood AB of mass 12 kg, length 5 meters. Here also still we don't know whether this rod is uniform or non-uniform. It rests in horizontal position on two smooth supports. One support is at end A, it's at this one corner of the rod, and the other support is at the point C, 0.5 meters from B. Here the length is 0.5 meters, right? As shown in the diagram. One girl of 30 kilograms standing at B. Therefore, you can mark 30 G over here, right? By modeling the plank as a uniform rod, if it is a uniform rod, you can mark the center of gravity is 2.5 meters from this corner. And the girl as a particle, that means you can mark straightforward the weight over here. Find the reaction at plank A. So you can mark reaction RA and RC there because they haven't given any specific relationship for these two forces, right? Then the weight 12G works downwards, and the weight due to the girl of mass 30 kilograms, 30G over here, right? Okay. Then I'll consider the moment around C. What is the advantage of getting the moment around C is, then you can ignore the moment due to RC and you can get expression independent from RC. Clockwise moments equals to anti-clockwise moments. If I consider the clockwise moments, this force and this force generates a clockwise moment. If I hold it from here and if I apply a force, it rotates this way. That is clockwise. And this one also, if I hold it from here and if you make a force over here, that one more makes a clockwise moment. But this force would be anti-clockwise moment. So the distance from here to here, we know that total length is 5. This length is 0.5. Therefore, this length would be 4.5. 4.5 into RA plus this force 0.5 into 30G equals to 12G into this length would be, how do you get that length as 2 meters over here? We know that this is a midpoint. Here to here is 2.5 meters. We know that this length is 0.5. It's from the previous information given in the question, right? Okay. Then you can mark 12G into 2, right? So you can mark RA into 4.5 plus 30G to 0.5 equals to 12G. This goes into 2 meters. With that, you can obtain the answer over here. RA into 4.5 equals to 12 into 2 is 24G minus 30 to 0.5 is 15G, 9G divided by 4.5 would be 2G. G is 9.8, then it would be turned up to 19.6, right? Yeah. When you come up to part B, the girl gets off the plank, right? She was here. Now it's moving to the different position. A boulder of mass 9 kilogram is placed on plank A. Okay, and man of mass 96 kilograms stand at plank B. Now the girl is totally removing from the system. So now there's a change makes in the system. Therefore, the reactions are not as previous. That is a first fact where we can understand. Modeling the plank against uniform rod and the man and the ball as particles, find the value for M, right? Okay. Let's come up with this question, right? So here there was a mass over here, therefore mg, and here the man is standing 96 kilograms, so therefore 93, sorry, not 96, 93g. Here the reaction is rx, and here the value is 12g. I'll consider the moment around C. Clockwise moments equals to anti-clockwise moment. So these two forces generates anti-clockwise, whereas this force generates a clockwise moment, right? Okay. Then there is a fact of point. There is another fact they mention. The girl gets off the plank. The boulder of mass is placed at E, and the mass of this much at B. The plank remain in equilibrium. It's on point of tilting about C. What do you mean by tilting about C? If the object is tilting about C, here the reaction at A becomes 0. That is why there is no component came over here, and the reaction A as 0. That's a point you have to understand, right? Then we can consider mg into 4.5 plus 12g into 2 equals to 93g into 0.5. If you simplify this answer, you can obtain the answer as m equals to 5. So that is the answer for that part of the question. If you come up with a question number 8, right? A plank AB has a mass of 50 kilograms. Length 4 meters, still don't know whether uniform or non-uniform. The load of mass 25 kilograms attached to the plank at B. So you can mark 25G downwards over here. A loaded plank is held in equilibrium with AB horizontal, two vertical ropes. There would be two reactions. Still, we don't know these reactions are any relationship between these two. Therefore, just keep it as it is, right? Okay. The plank is modeled as uniform. Therefore, you can mark the center of gravity is at the midpoint of 4 meters, 2 meters from this corner or whatever the way, right? Okay. And given that there's another fact is given that the tension in the rope C is 4 times of the tension at A. So here the tension is 4 times of the tension at here. Therefore, you can mark here the tension as T. Therefore, this would be 4 times of it, sorry. 4 times of it, this should be 40, right? Let's see how to mark these facts, right? The question what they request is, calculate the distance from C to B. From which length you have to keep this rod to keep the such equilibrium, right? Okay. Then I'll consider the upwards forces equals to the downwards forces. What are the upwards forces? T and 40 equals to downwards forces 50G and 25G, right? With that, 5T equals to 75G, T equals to 15G. With that, here the tension over here is 15G and here the tension would be 60G, right? Okay. Our question is to find the length of C, right? Okay. This length X only, we have to find it. Then I'll consider the moment around B, right? Then you can see that these two perform clockwise moment, whereas this perform an anti-clockwise moment. So here the length is 2. The total length is 4. So this is the midpoint over here. There should be, this length should be 2. 2 into 50G equals to the value for this much, right? This value is 40, that is 60G. 60G into X plus this length is 4. 4 into 15G, T is 15G. So you can get the answer 50G to 2 is 100G equals to 60GX plus this is 60G. So all the terms contains G, therefore you can cancel all G at once, or you can write 60GX from here. 60GX equals to 100G minus 60G, that is 40G divided by 60G. With that you will obtain the answer for X as 0.666 or 2 over 3 meters from P. That is the answer for X. If you come up with the question number 9, right? The beam AB has a weight of 200 newtons and length of 5 meters. Still, we don't know whether this is uniform rod or non-uniform rod. So therefore, we just go ahead with the question. The beam rests in equilibrium in two horizontal positions on two smooth supports, right? Okay. One support at A and the other support at C. The beam where BC is 1 meters. Therefore, here the length should be 4 meters, right? Shown in the diagram, the beam model as a uniform rod. Therefore, center of gravity is exactly midpoint 200 newtons, right? Find the reaction at beam C. Therefore, there is no specific relationship between the reaction A and C. I just mark it as RA and RC. This is the force only 200 downwards, right? Okay. Then we can work out. I'll consider the moment around A. Then you can work out clockwise moment 2.5 to 200 equals to anti-clockwise moment 4. Here the length is 4, 2.5 plus 1.5 into RC. With that, you will obtain the answer RC as 125 newtons, right? Then let's go ahead with the part B, right? The woman of 500 Newton stands on the beam at point D. Still, there is no specification given with D. That means we need to find the value for length to D. The beam remain in equilibrium. The reaction at beam A and C are now equal. Now you can mark two reactions equal, and the length of A to D would be X. I'll get it as X. The length, the weight is 500. Why it's 500? Because its weight is 500 newtons, right? The rod, the weight of the rod is 200, which works at 2.5. The additional information for the question does not affect for the center of gravity of a rod. Its length is from here to here is 2.5 to 200. Then I'll consider the length of AD as X. Then if I consider the upwards forces equal to downwards forces. So you can work out 2R is equals to 500 plus 200, 700. That means each reaction would be 350 newtons. Then I'll consider the moment around A. These two are clockwise moment and this would be anti-clockwise moment. X into 500 plus 2.5 into 200 equals to 4 into R. 4 into R equals to 200 into 2.5 plus 500 into X. If you simplify, you will obtain the answer as R 1400 equals to 4R. If you work out, 4R is equals to 200 plus 200 into 2.5 plus 500X, right? Then we know that 4R is equals to 500 plus 500X. Then R is 350. Then we can say 4R is 1400 is equals to 500 plus 500X. Then X is equals to 1.8 meters. That is the way of obtaining the answer for this part of the question, right? This is the last question in this video. So let's move up to that question and try to obtain the answer. A beam of a crane is modeled as a uniform rod of AB, length 30 meters and weight 4,000 kilograms. So you can mark the weight as a midpoint 4,000 G. Resting in a horizontal equilibrium. The beam is supported by tower at C, where AC is 10 meters, and a counterbalance of weight 300 kilograms, that is to what you call block down, what you call the break up from this end. You are keeping some kind of a balancing weight over here in the crane, placed at A, therefore the weight is 3000 G, and the load of mass M to place a variable distance of X, that is to according to the force we apply over here, we can what you call keep the system much conveniently balanced. That is why we're keeping a mass M at a variable length of X over here, right? X from the from supporting tower where X is greater than 5. So you know that obviously you have to keep this mass at a distance of more than 5 meters, right? Find the expression for M in terms of X, right? Let's see how to do this question. Here we know that here the reaction is R, I just mark it. Here the weight is 300 G, here the weight is 4000 G, and here the weight is mg, right? How do you get that, right? So from where does this 4000 G came? Because we know that the weight of the rod is 4000 kilograms. So that is the, it's a uniform rod, so it should become up the midpoint over here. That's a way to get it, right? So you know the total length is 30, here the length is 15. If this length is 10, this should be 5, right? Okay. Then we can consider the moments around C. But the use of getting the moments around C, therefore, we can get expression. We can obtain an expression independent from R. So clockwise moments equals to anti-clockwise moments, right? Okay. 3000 G into 10. The anti-clockwise moment equals to 4000 into 5. 4000 into 5. The reason is that midpoint of 30 is 15. Here this is 15, where the weight of the rod acts, and here the length is 10, means this length should be definitely 5 into mg into x. So you can work out m is equals to, if you simplify, 10,000 over x, right? Then the next part of the question, right? Hence determine the maximum and minimum load for can be lifted by the crane. This is pretty simple. We know that m is the weight you added, is it should be 10,000 divided by x. At the beginning of the question they mentioned x is less than or equals to 5. So definitely x should be greater than or equals to 5. So if you substitute 5, you will obtain the answer as 2000 kilogram. Then the maximum length you can go ahead from here to here is 20 meters. Why? The total length is 30. If this length is 10, this should be definitely 20. So if you put this x as 20, you will obtain the answer as 500 kilograms. Out of these two, therefore, the weight you can add it over here would be in between 2000 to 500 kilograms. That is what you need to understand from this question, right? Criticize this model in relation of the beam. So what you can get here is, you can say that it's not a very accurate model, the model as a uniform rod. Since the beam may be taper as one end, the center of mass of the beam not may be lie in the middle of the beam. Obviously, we know that if you make a arm for a crane, it is not a uniform rod. Slight weight variations are there. In that is the main problem where we come across when you are getting this assumption, right? Hopefully you have understood the contents in this video. If you like this video, please put a thumbs up and share this video with your friends. To watch more educational videos, please subscribe my channel and click on the bell icon. See you from next videos. Thank you.